Friends, myself Shubham Sogule, and today we are going to discuss about sensors and transducers. Sensor is a device which used to sense physical quantities or non-electrical quantities and which produce electric signals, and transducer are those which use sensors and signal conditioning, and it gives you electric signals. Okay, first one by one we will discuss about sensors and transducer. Sensor is an element which produce signal corresponding the quantity being measured. Okay, now here in first box, if you see, what is the electrical or non-physical quantities we are giving as an input, and sensor sense that and it produce respective electric signals. Now here, what kind of physical quantity we can measure over here? Temperature, pressure, force, motion, displacement, humidity, light and flow, etc. Okay, now when you give these kinds of physical quantities, it convert into what signals, in what electrical form? It convert into resistance, inductance, capacitance, etc. Now transducers, here if you see, it is a combination of sensors and signal conditioning. When you are giving input in terms of non-electrical quantity or physical quantity, it senses that and it conditions to the signal, and it gives you an output. Now classification of sensors. Here you can see humidity sensor, which used to measure the humidity, pressure sensor to measure pressure, displacement sensor to measure displacement, velocity sensor for velocity measurement, force sensors to measure forces, flow sensor to measure any kind of flow of a fluid, thermal sensor to measure heat, temperature sensor to measure temperature, proximity sensor to measure the presence of any element. The example of proximity sensor, this is very relevant to you guys, because everyone has the smartphone. If you are calling someone and if you take that mobile to nearer to your ears, what will happen? The screen will get off. Why? Because near that front camera and speaker, there is one proximity sensor which senses the presence of your body or any element, and if you take a hand over there also, it senses the presence and it will off the screen. This is how proximity sensors works. Now classification of transducers, broadly classified into two types. First is analog transducer and second one is digital transducer. And in analog there are types like electrical type and optoelectrical transducer, and in digital transducer frequency domain as well as digital encoder. And again in electrical type and optoelectrical transducer, there are so many classifications like potential electric transducer, potential electric resistance type, inductive type, capacitive transducers, piezoelectric transducers, resistance strain gauge, and so on. Okay, now the performance terminology. Here we will see how properties of transducers. Okay, range, first one is range. If you want to, if you see any machine, it having some range, within that it works, means plus or minus, within that only it works. The best example for this, if you see a weighing gauge machine, there you can see some weight load range, means above that load you can't put any more, because that is the range of that weighing gauge machine. Or if you are having AC, some range they give, means in from 10 degrees Celsius to 30 degrees Celsius it can works, means that temperature it can give you. Above that or below that it can't give you. That is called as a range and span. Okay, then error. The best to understand this error, we can take an example of AC. If you want a room temperature of 25 degrees Celsius and your AC is giving you 26 degrees Celsius, then what is the error? It is a 1 degree error, 1 degree Celsius error. And the same way, if you want a 25 degrees Celsius but your AC is giving you 24 degrees Celsius, then what is the error? It is again 1 degree error, but this is plus and this is minus, and the accuracy is nothing but that only. It is like a summation of possible errors, means positive and negative, within what it works, that is called as an accuracy. Then sensitivity. Sensitivity is defined as ratio of output to the input, or relationship indicating how much output you get per unit input. That is called as a sensitivity, means the best example for this, take a weighing gauge of kirana shop and take the weighing gauge of goldsmith. Okay, if you put a paper piece, cut a paper piece and put on the kirana shop weighing gauge machine, and put a same paper piece on goldsmith weighing machine, which machine give you a proper weight, or which machine can sense that weight of paper, that whatever you have kept over there? Obviously goldsmith machine will work better than that machine. Why? Because the sensitivity of that machine is more compared to that machine. This is called as sensitivity. Repeatability means again and again, whenever you are start measuring again and again, it gives you same output for the same input. That is called as a repeatability. The example for this, if one student is scoring 35% throughout his college days, and one student is scoring first semester 35%, next semester 50%, next semester 60%, next semester 90%, who is repeatedly doing the same thing? First one, because his output is continuously same throughout his all semester. But another student, whether it is he is improving himself, but he is giving different outputs. This is called as a repeatability. Now stability. Stability, it can be defined as ability to produce, to give same output when used to measure constant input over a period time. This is called as a stability. And dead bond, next one is dead bond. Dead bond is a space, the transducer range where it doesn't work. Means the best example, that is weighing gauge. Again, if you put a paper piece on a Kiran shop weighing gauge machine, what will happen? It doesn't show any reading on the display. Again you put little bit more paper, again you put little bit more paper weight, what will happen? After some papers it starts showing you a weight. The below that range we can say it having dead bond of that machine. Okay. Resolution, next one is resolution. Resolution is nothing but some signals are very in the sense are very small, or it having very low intensity, and the getting output from those signals, it is very difficult. To improve that means if you are taking some input as a very low intensity signals and making or amplifying those signals is known as resolution. Okay, the next is output independence. Sorry, output impedance. This is nothing but for while transferring signals to the output, what happens? Some resistance you face, that is nothing but output impedance. Thank you.